So we continue with we keep solving this MCQ, and we continue with question number 3, because in the previous video we solved question 1 and 2. Okay, now consider f defined on an interval I. Okay, and f of and then we say that capital F of x is a primitive of small f of x on I if. Now let's try to clean this new page. Okay, so this is a theoretical MCQ. So we're talking about MCQ related to theory. We want to understand what means that a function capital F, okay, is a primitive. Is a primitive of the function small f in I. So suppose that you have on some interval I. Your interval maybe start here and end here. This is the interval I, okay, and on the interval I you have this function like this, and I want to tell you that this is your capital F of x. You say that capital F of x is the primitive of small f of x. What does it mean? In your mind, for students, it means that the derivative of capital F of x gives small f of x. Yes or not? So saying that capital F of x is the primitive of small f of x means that if I derive capital F of x, I will get small f of x. Yes or not? But the question is that, so if I but this should happen, so capital F of x is the primitive of small f in I, in the interval I, if for all x that I take in I, okay, at any point that I take in I, the derivative of big F at that point will be equal to the small f at that point. If you want, for all x0 that I take in I, f prime, the big F prime of x0 should be equal to small f of x0. This should happen for all the point in I. Is that clear? So to say that big F is the primitive of small f in I, whatever is the point that I take in I, the derivative of big F at that point should be equal to small f at that point. Is that clear? And it should happen for all the point in I. Now that is why, look, the statement A says that big F is differentiable and there exists one point in I such that the derivative of big F is equal to the one of capital F. It is false. This should be equal at every point, not at a single point. Yes or not? The derivative of big F should give small f at each point, not at a single point. Is that clear? Now B says that f is differentiable on I and f prime of x, so the derivative of big F at any point is equal to the derivative is equal to small f for all x in I. This is true, yes or not? It's true. So the answer is actually 3B, right? Now students used to attack because D and E are obviously false. Yes or not? The primitive has nothing to see with the second derivative, and E is saying that it look like the big F is the derivative. B is saying that small f is the primitive of big F, right? But we don't want it. We want big F to be the primitive of small f. Now my point is that usually students believe that if capital F prime of x is equal to small f of x, then the integral of f of x will be equal to capital F of x. This is what students believe, but it's not always true. Look, so I mean, when you we cannot if f prime of x is equal to small f of x, the integral of small f of x will not necessarily turn back to the same f of x. Yes or not? For example, look, if I give you capital F of x equal to x squared, doubts? I give you capital F of x equal to x squared. What is clear that the small f of x will be 2x. Yes or not? But now if I integrate 2x, but this integral, it can give me x squared. Yes or not? It can also give me x squared plus 1. It can give x squared plus 3. It is x squared plus any constant. Okay? So what does it mean? It means that you cannot, the concept of primitive is defined through the derivative, not through the integration. So if the integral of f of x is equal to if f of x is equal to the integral of f of x in dx, okay, this do not means that f of x is the primitive this happen for all x in I. Suppose that this integral is equal to this for all x in I. This does not mean that f of x is the primitive of big F of. Is that clear? So to say that the definition of the primitive should be given by the differentiation operator, not by the integration operator. Is that clear? Also, because this stuff f of x equal to a single function, this stuff is meaningless. So this stuff, when you something like this is meaningless, because this is just one function, right? But how many functions you have here? Infinite many. When you integrate like this, you have infinite many possible forms. How can one function be equal to infinite many functions? So pay attention to this mistake. The primitive is defined through the differentiation, through the derivative operator, okay, not through the integration. Okay, nice. Now we move to quiz 4. Okay, maybe is that clear? Okay, so we move to quiz 4 and we do a new. So in quiz 4 we say calculate the following integrals. So the integral is the integral of 1 plus 1 over x, 1 plus 1 over x all square in dx. Okay, clearly written like this, maybe the best thing to do is to try to expand, right? To say it will be 1 plus 2 over x plus 1 over x squared in dx. Yes or not? Now you can write it like the integral of 1 in dx plus the integral of 2 over x in dx plus the integral of 1 over x squared dx, right? Equal to the integral of 1 is x. The integral of 2 over x. What is the integral of 2? Remind you that there is also an important formula saying that the integral of f prime over f is the logarithm of absolute value of f, right? So if you do here, you have 2 over x. This is 2 over x. You can take 2 out, right? It will be the integral of 1 over x, so it will be 2 times the logarithm of the absolute value of. Yes or not? Here you have plus. This is the integral of 1 over x squared. The integral of 1 over x squared It's like writing the integral of x to power minus 2 in dx. But the integral of x to power n is x to power n plus 1 over n plus 1. So the integral of x to power minus 2 will just be x to power minus 1 over minus 1 equal to let's say equal to minus 1 over x. Is that clear? Okay, the question of my student is how to explain the steps again. So the integral of x to power n is x to power n plus 1 over n plus 1. This is a formula. We have to do the integral of x to power minus 2. So n is minus 2. Minus 2 plus 1 will be minus. So we get x to power minus 1 over minus 1. X to power minus 1 over minus 1 means this minus 1 will be minus x to power minus 1. So my x to power minus 1 is 1 over x. So it's minus 1 to power over x. So this integral here, this one here, gives you minus 1 over x. Okay? Plus. We needed the what? We square it, yes. Okay, so okay, nice. Okay, and thus let's go back on the PDF to see if we have our so the answer is D, right? The answer is D. Okay. Okay. So the answer is 4D. Well. Okay. Our answer here. Excuse me. So it is 4D. Okay. Okay. Nice. So we also stop this recording section here, and we continue in the next video. Okay. So